Welcome to this recreation of the setup that resulted in the first true forerunner of the mill standard 461 RE02 RE102 limit and test method. This is a recreation of a setup described in a document called NADC EL5515. NADC stands for the Naval Air Development Center. That was in Johnstown, PA. The document was written by William Jarva, who was also the author of MIL-I 6181B as in Baker. That's the first modern EMI, military EMI standard. When I say modern, I mean it was based on the science of making electrical measurements that actually mirrored the interactions that would occur on the platform. So just to go around here and look at the setup, first off is the victim of interest. This was a receiver like this one, the BC-348Q. This was a World War II era receiver that could be found on B-24s, B-25s, B-26s, B-17s, and B-29s. This receiver is actually the one that was used in NADC EL5515, which is essentially the rationale behind MIL-I 6181B. The most important part of this receiver, and from the point of view of EMI, is the antenna connection, which is shown right here. And you can see it's not coaxial. You can see A is for antenna and G is for ground, and you can see that we've actually connected ground to the ground plane underneath. The antenna wire is a copper wire covered in steatite beads held above ground by these porcelain standoffs. And in the original NADC L5515 test, it actually went all the way up to the ceiling and out to a stub or some kind of termination. I think it was a capacitor to represent the electrical length, the short electrical length of the external antenna. But this is all the steatite beading I had. So I just stopped it right there. And up here you can see that this is the power to the box. The box is not, the receiver's turned off, but I've got 28 volts applied. And then the power is applied through a listen. Notice it's a single listen, which means that the 28 volts returns on the ground plane underneath the listen, which is the way they powered boxes, all 28 volt boxes in metal aircraft in those days. And then finally we have the noise maker here, the device that's going to cause the noise to which the BC-348Q receiver will respond. And on top of this impulse generator, which is an impulse generator from the time, but maybe not as far back as 1953, here's an example of one kind of noise maker they used to generate noise, and this is called a dynamotor. And basically it's a motor generator set. It's 28 volts in DC, 250 volts out DC, and the purpose of these was to generate the high DC potentials to operate tube type equipment. There's a dynamotor similar to this one right behind this plate in the BC-348Q, which provides a bias for its tubes. Okay, so in lieu of powering up such devices, I'm using a Stoddard impulse generator connected to a rod antenna. The rod antenna is roughly equidistant from the steatite wiring and the 41-inch rod antenna connected to the ANPRIM1, ANPRM-1. This was brand spanking new in the early 1950s. By the way, 6181B, B as in Baker, is dated 1953. The work that was done to generate it obviously happened before that date. This is the machine that they used in NADC EL5515 to monitor, to measure the field levels when the BC-348Q was susceptible. So when this thing was susceptible, they would write down the meter deflection, and that was called an antenna-induced limit, meaning that it was not a field intensity measurement. It was actually just the voltage at the base of this 41-inch rod that screwed right into the battery-powered case of the ANPRIM1, whose only ground, as you can see, is the short bond strap to the ground plane, and this is meant to mirror the setup in MIL-I-6181B that you can see right here in this picture out of the MIL-I-6181 series. So with that said, we're now going to go ahead and turn on the BC-348Q. One thing I neglected to mention was that the separation here between the 41-inch rod antenna and the test sample is on the order of a foot. In other words, this position right here is supposed to be a foot back from 4 inches back from the ground plane, which is the place at which all the test equipment under test is supposed to be positioned. And that's 1 foot as opposed to the modern 1 meter. And that was based on the fact that this D-type wiring could be within 1 foot of a culprit wire. So, having said all that, we're going to now go ahead and energize the BC-348Q. Okay, you can see the light came on, and we're going to go over here, and we can see about 2 amps of, actually it's still coming up, steadies out at about 2 amps of current draw from 28 volts. And so, having turned that on, now we're going to bring up our noise generator, our impulse generator. Turn this thing all the way down pretty much. You can hear the impulse generator you can hear it cycling. Now we're going to bring up the level. You can start to hear noise out of the speaker. By the way, that speaker would not have been in use on the aircraft. The headsets draped across the speaker would have been in use, but for the purposes of this video, I hooked up the auxiliary audio output into a speaker so that the interference could be heard. Okay, so now we can clearly hear the noise, and if there's any doubt, we can hear this. Turn this off and it goes away. Okay, and so the point would have been to have gotten somewhere down towards a threshold of susceptibility and to at that point have monitored the AM prim 1 indicated level and to write that down, and then that of course would become the limit at that particular frequency, and then you would pick a number of frequencies across all of these different bands. This thing switches in octave bands, and that was the basis of the rod antenna limit below about 20 or so megahertz, because the BC-348Q could only tune to about 18 megahertz. So that is how the original forerunner to REO2 came about. And the key thing about that is the use of the 41-inch rod, which was part of the equipment set that came with this receiver, the AM prim 1. The fact that it was a foot away from the noise generating equipment, and that they recognized that because of this high impedance wire and the input to the BC-348Q was high impedance, that they needed to use the 41-inch rod, which is a high impedance device, rather than the what was called the loop input to this receiver, which it also came with. So this is the genesis of the use of the 41-inch rod and the reason behind it back in 1953. Thank you.